Hey guys, today I'm going to be showing you what they call hidden quadratics, so how to solve them by multiplying both sides of the equations by x to the power of a half, and you have to excuse the kind of sloppy writing because there wasn't any like text version of this. Anyway, take x to the power of a half, so x to the power of 3 over 2 plus 20x to the power of minus half equals 9x to the power of half. Now that looks pretty bad, fair enough, but remember it's told you by multiplying both sides by x to the power of a half. And when we multiply powers, we can literally just add them. So we're gonna add half to each of these powers here, and you're gonna see that it becomes a bit easier to work with. Now that doesn't look amazing either, but as soon as you simplify these fractions, you'll see why they call them hidden quadratics. And remember, x to the power of 0, but anything to the power of 0 is just 1, so we could just write this as 20. And remember, x and x to the power of 1 are just the same, so we can kind of ignore this here. Once you get to this point, you can see how it's actually just a quadratic equation, and we just have to rearrange it to make it equal to 0. So, yeah, I think these are kind of one of the nicer questions you can get in a test paper because it's just what you already know. But anyway, at this point, we're gonna put this into double brackets like we always do. And so just like that, you've already got your two answers here. So you got a very similar question here. So by multiplying both sides of the equation by x to the power of a half, solve that. Now you notice it says for x is greater than 0. We can get onto that in just a sec. But what we're going to do is add the half to each of these powers. And so we're going to put these into the double brackets like normal, but this time we're going to have a positive and a negative bracket, which is actually going to be an important detail, and you'll see why in just a second. So normally what I would say is now here are your two answers, but remember it says for x is greater than 0. So as some of you might have guessed, this negative answer, we're not counting that because it's not greater than 0. So we're left with our single answer here, x equals 3. Alright, so we've got a slightly more difficult one here, and I'm not sure how well it's going to turn out in the video, the quality, so I'll just read it out. By multiplying both sides of the equation by x to the power of 2 fifths, solve x to the power of 8 fifths plus 12x to the power of minus 2 fifths equals x to the power of 3 fifths. So again, we're just going to add 2 fifths to each of the powers, so it's going to turn out like this. Alright, so obviously I just wrote minus 0 over 5, but you can basically ignore that because that is literally just 0. And I've just changed the thickness because I forgot to change it back. Anyway, we're gonna simplify the fractions. We're gonna make it easier to read. And so you've got your answers here, and so hopefully the method is kind of like self-explanatory now. But I'm just going to show you one more question that is a little bit more challenging, I suppose, but it will make sense. Alright, so here's a question with a graph that I've screenshotted directly from Desmos, but here is the graph of y equals x squared minus 6x plus 5 for values of x between 0 and 6. By drawing a suitable linear graph on the grid, work out approximate solutions to x squared minus 7x plus 9 equals 0. So what we're going to do here is we're going to take the graph, function, expression, whatever, and take away the other one. So remember that graph take away other. So we're going to do it here. So because we come out of that, we know that our line is going to be y equals x minus 4. I remember it did say a linear graph, so it's just going to be a straight line. So now you get to watch me have fun trying to figure out how to line this up. Alright, so now that we got it like this, we're just gonna draw our straight line like that. I'm gonna take away this ruler, and we can see that, well, we can see where the line crosses over, but what matters to us is when we go perfectly vertically up where it hits. So I'm just going to draw that on now. Or what I should have said was vertically towards the x-axis, because it's not always going to be up, obviously. Now it's not going to be perfect because I've just drawn it with this digital ruler, but from this estimate I would probably say it's around 1.75 maybe. And then if we look at the other one, I would say we're just going to say that's about halfway between. I would say that's about 5.5. I'll say 5.6 though, 'cause it's a little bit over halfway. And that's actually all you have to do. So obviously it'll probably be a bit clearer like when you're drawing it on the actual paper, but those are your answers right there. So I hope this video helped, and I'll see you in the next part.